Scientists found a paradox that violates the whole concept of the universe. The warmth of the sun is responsible for the emergence of life on Earth. However, our star's brightness is increasing, and it has not always been so strong. There is overwhelming evidence to suggest that the early Earth was a frozen sphere. There was no need for anything to sustain existence there. Despite this, there is evidence that water was abundant and life flourished. However, this isn't the only unexplained cosmic contradiction. Can something exist that predates the Big Bang? Why is the sky red today? In what ways can dwarf satellite galaxies revolutionize physics as we know it? Hey folks, welcome back to our channel. In today's video, we are going to discuss researchers uncovering a puzzle that threatens our understanding of the cosmic order. Firstly, make sure you have subscribed to our channel, and secondly, hit that bell icon for regular updates. And now, let's get ready to find out. On a huge cosmic scale, our little part of the universe isn't all that extraordinary. Our sun is a yellow dwarf, which is rather odd. Because we know our home star best, we might believe yellow and white dwarf stars, or FGK dwarfs, are abundant in the cosmos. They are not the most numerous stars in the cosmos. In fact, red dwarfs are. Red dwarfs, also known as M dwarfs, make up 75% of Milky Way stars and are colder and longer lived than the sun, and longer lasting. Red dwarf stars are projected to survive billions of years. Since the Big Bang, 13.4 billion years ago, no primary sequence has reached its end. Since red dwarfs are so plentiful and steady, we shouldn't consider ourselves cosmically special. It's odd that we're not orbiting one. We orbit a rare yellow dwarf. The big red sky paradox is a corollary to the Fermi paradox, which concerns why we haven't found intelligent life in the universe. Solving this conundrum would guide future remote life detecting research and universe life boundaries. Red dwarf stars are good candidates for alien life. They don't burn as hot as sun-like stars, thus habitable exoplanets must be closer. Exoplanets that orbit their stars more regularly than Earth could be easier to locate and study. In this habitable zone, scientists have found many rocky exoplanets like Earth, Venus, and Mars. Some are close. Red dwarf stars should hold life somewhere, so astrobiologists are looking. Kipping's paper offers 4 red sky paradox answers. Unusual resolution. First, we're weird. If life arises at similar frequencies around both star types, Earth is an exception and our emergence orbiting the Sun was a 1 in 100 chance. That would contradict the Copernican principle, which asserts that there are no privileged observers in the universe and our place is normal. Outliers mean our place isn't normal. This isn't an impossible or satisfying answer. The other 3 resolutions are more satisfying and testable. Resolution 2, red sky restriction. Kipping argues that yellow dwarfs are more livable than red dwarfs, hence life emerges 100 times less often around red dwarfs. This theory is well supported. Red dwarfs, for example, have lots of flare activity and no Jupiter-like planets. Theoretical study has questioned the viability of complex life on M dwarfs due to tidal locking and atmospheric collapse, increased exposure to star activity, protracted pre-main sequence periods, and the paucity of Jupiter-sized companions, Kipping stated. Resolution 3, a simplified life. Argument: red dwarf stars haven't had enough time for life to form. This is due to the star's pre-main sequence phase before it starts fusing hydrogen. This condition lasts a billion years for red dwarfs. During this time, livable worlds could experience a runaway permanent greenhouse effect. This could suggest that white and yellow dwarfs have a longer window for complex biology on rocky planets than red dwarfs. And number 4, pale red dots. Even while 16% of red dwarfs with exoplanets have rocky planets in the habitable zone, they may not be as prevalent as we anticipated. Our survey sampled the most massive red dwarfs because they're the brightest and simplest to study. What if the tiny ones, about which we know less, don't have habitable zone rocky exoplanets? Intelligent life is scarce in the galaxy and spawns between M and FGK dwarfs, although habitable worlds are 2 orders of magnitude less numerous around M dwarfs than FGKs. This 2-order of magnitude disparity makes for an interesting explanation. It would necessitate that Earth-sized temperate planets near M dwarfs are unfriendly to life, or that late-type M dwarfs, or low-mass end, rarely host habitable worlds. It's likely that multiple resolutions are needed, which would reduce the impact on any one. We may hear soon. As our technology improves, we can observe lower-mass red dwarf stars and look for planets orbiting them. So this is the end of our video. We hope you enjoyed it. Please subscribe to us for more space facts, discoveries, and more. Thanks for watching.